Hello guys, my name is Nyasan Zenza. I'm with my partner Tkalani Kiwa. We're fourth year electrical engineering students at the University of the Witwatersrand. We'll be taking you through a presentation detailing our project, investigating ultrasonic atomization using image processing for fluid mixing applications. The following details the presentation structure. Feel free to pause or rewind the video at any point if any information in the section needs to be clarified. The project defining terms are presented below. The key concept under investigation for this project is ultrasonic atomization, which is the breaking down of bulk fluid into smaller particles. Ultrasonic cavitation is another important concept caused by the presence of vapor bubbles due to high velocity fluid movements and aids in the mixing process. Image processing will be used for data collection and analysis in this project. We will be observing the behavior of two transducers under the same test conditions to identify the most suitable transducer for mixing purposes. These are the two transducers. The operation principle of the transducers is they draw small amounts of liquids to their surface using a principle similar to that of the siphon, and they begin to atomize. The liquids used for testing and the given properties are shown here. Two experiments are carried out. This is the schematic for the first experiment are set up. This is the actual setup. These were the steps taken for the project. 1. Experiment carried out. 2. Video recorded. 3. Video and image processing carried out. 4. Data analyzed.
After the experimental setup was ready, a video of each jet was recorded and transferred into MATLAB, where it was separated into its individual frames. Each frame then undergoes steps or a series of edits in order to allow for the easy extraction of data. From each frame, a binary edit was used to calculate the maximum pixel height using an algorithm, and the algorithm stores, averages, and plots the results. The results show that transducer 1 achieves higher atomization height per voltage per liquid as compared to transducer 2. Transducer 1 was tested using experimental setup to test for the rate of atomization in grams per second. The experimental procedure is detailed in this slide. The overall experimental analysis is detailed below. To prove that indeed transducer 1 can be used for mixing, a prototype was built with a floating device, and this floating device ensures that the transducer is kept afloat throughout the mixing so that as little liquid as possible is in contact with the transducer.